Today we're going to talk about functions and their graphs. A relation is a mapping or pairing of input and output values. So if you have x values and y values, it is a relation. Remember, input is x's, output is y values. The domain is the set of input values, the x's. The range is the set of output values, the y's. A function is a special type of relation where there is exactly one output for each input value. Okay, so in numbers 1 and 2, we need to identify the domain and the range and then decide, is this relation a function? So first of all, let's identify the domain and range. The domain is the input, so -2, -1, and 0. The range is the output values, 5, 6, 7, and 8. On number 2, I would like you to write out the domain and the range. So on your own, write out the domain and the range for number 2. To determine if the relation is a function, we have to make sure there is exactly one output for each input. Each input can only be matched with one output. So here is a problem. The input 0 can only be matched with one output value. It is currently matched with 2 output values. So this one is not a function. We could take this mapping diagram and create, I think the arrows are a little bit shifted, but I think you can tell where they're technically going. But you could create ordered pairs. One of these ordered pairs is -2, 6, because the input -2 maps to the output 6. Another one is -1, 5. Then we've got 0, 7, and 0, 8. The thing that you're looking for when you're deciding if it's a function or not is if there's a repeated x value. Repeated x values make it not a function. So you may want to write somewhere that repeated x values make a relation not a function. Repeated y values are fine, but repeated x values are not okay. So what do you think about number 2? Is it a function or not a function? It is a function. If you wrote out these values, you got 5, 1, 9, 7, 11, 7, 12, 0. There are no repeated x values, so it is a function. Okay, so there's multiple ways to express a relation. There's mapping diagram like this. There's ordered pairs, which I wrote out here. We can also use a graph to display a relation. So here's the relation: 2, 5, -1, 7, 0, 1, and 1, -4. Okay, I like to use this type of grid when we're graphing, because if we needed to put our origin here, if we had points that were bigger and we needed to put our origin here, we could. I also like that it has darker lines every 5 units, so it's easier to, like, if you have to graph the point 9, 9, you can find that easier without having to like count every single one. So technically, I should tell you that we always have to draw in our axes, but are you guys okay with just making an agreement that if we don't draw the axes in, this middle point is the origin. That middle point is 0, 0. If we want to move that origin somewhere else, if we want it to look more like this, we have to draw the axes in. So let's just make an agreement that if no axes are drawn, that middle point is 0, 0. Is that a good assumption? That way we don't have to draw the axes every time, because I don't know about you, but I'm not good at drawing straight lines every time. So that point right there in the middle is 0, 0. Let's graph 2, 5. 2, 5. Remember, in an ordered pair, you always graph side to side first, then up and down. -1, 7. 0, 1. And 1, -4. Is the relation a function? Yeah, check your x values. Do we have any repeated x values? We do not have any repeated x values. So yes, this relation is a function. What if I added the ordered pair 1, 5? Then it would not be a function, because we would have the repeated x value of 1. This leads us into the vertical line test. If I draw a vertical line through that point that I just made, a vertical line touches 2 points in that relation. It touches 2 points because a vertical line has the equation x equals something. So if 2 points hit that line, you have a repeated x value. A vertical line is just checking, do you have a repeated x value? So if a vertical line intersects the graph at more than 1 point, it is not a function. If vertical lines don't intersect more than 1 point, it is a function. So imagine putting hundreds, thousands, millions of vertical lines through this. Would any of those vertical lines touch more than 1 point at one time? No. So this one is a function. The second one, it looks kind of steep, but if you were to zoom in, even if you put a vertical line through a really steep spot, it still only touches 1 point at a time. So that is a function. What about the third one? A vertical line would definitely touch more than 1 point at one time, so this is not a function. Okay, so on your own, I want you to pause the video, graph the relation, tell whether the relation is a function. Okay, here's the graph of the relation. Is it a function? Yes, it is a function. A linear function is a function that can be written in the form y equals mx plus b. And I know that you've seen this before. Function notation. F of x equals mx plus b. I want you to write out somewhere f of x means f of x and it is the same as y. So y equals mx plus b, f of x equals mx plus b. F of x equals is exactly the same as saying y equals. It's a label. It means the same thing. It does not mean f times x. It doesn't mean anything like that. It's just a label that gives us a little bit more information. So first we need to decide, is this function linear? And then we need to evaluate the function for the given value of x. The first one is kind of a trick. Those bars, we've seen those recently, those are absolute value bars. Absolute value is linear. So I'm just going to make a note that absolute value is linear. We need to evaluate f of -6. That label means take the function that we labeled f, plug -6 into it. So we would take the absolute value of -6 minus 5. The absolute value of -6 is 6, and 6 minus 5 is 1. So technically our answer should look like this. F of -6 equals 1. Here's why mathematicians love function notation. I can look at this answer and see you took the equation that we labeled f, you plugged -6 into it, and you got 1 as your answer. So this label tells me that the point -6, 1 is on this graph. It's a label that tells you a lot more information than just y equals 1. If you tell me y equals 1, it's like, are you talking about a horizontal line? Are you talking about the answer? What did you plug in to get that? It just doesn't have a ton of information. So function notation gives us more info. Okay, number 7. First, we need to decide, is it a linear function? I'm going to circle the thing that you should focus on. Linear functions look like mx plus b. Plain ordinary x, no squares, no cubes, no square roots, nothing crazy like that. So if this one has x squared in it, is it linear? No. So we would say not linear. But they still want us to evaluate the function even though it's not linear. 2/3 times 4 squared minus 4 plus 5. And you could absolutely plug this into your calculator if you wanted to, or you could do some mental math, whichever you want to do. 4 squared is 16. 16 times 2 is 32. 32 divided by 3, of course, it's not a nice number. Minus 4 plus 5. I got 11.6 repeated, so I'm going to round it to 11.67. Okay, why don't you try number 8 on your own? First, I want you to think about, does it look like it's a linear function or not? And then plug that -7 in and see what you get. This one definitely looks like mx plus b. It does not have any funky things going on with x. If we graphed this, it would form a line. So yes, this one is a linear function. F of -7 is 2 times -7 plus 3. That'd be -14 plus 3. So -11. Did you get -11? Yeah. Awesome. And that is it for today.